Countless universes drift silently in the boundless expanse, each a luminous bubble floating in an infinite cosmic ocean. They shimmer with stories untold, possibilities uncounted, worlds that might have been and worlds that could still emerge. Light bends and stretches around them, casting shadows across the void, painting the darkness with the faintest brush of eternity. Time itself flows differently in each bubble, a river of moments that rises, falls, and folds back upon itself, in patterns too intricate for the mind to hold. These universes are not isolated. They hum with a subtle resonance, an echo of each other's existence. It is a chorus without a conductor, a symphony of potential, vibrating across the fabric of reality. And yet, beneath this delicate harmony lies an unsettling question. What if all these threads were not meant to coexist? What if, like fragile glass, they could shatter, merging suddenly into a single, overwhelming current? To imagine such a convergence is to see rivers of time and possibility colliding into one immense sea, carrying every history, every future, every version of ourselves in a torrent too vast to comprehend. It is a cosmic inevitability, perhaps, dictated by the hidden laws of quantum mechanics and the relentless pull of entropy. Would such a collapse annihilate us, fusing every identity into an indistinct shadow? Or might it reveal a deeper pattern, a secret architecture of existence, hidden beyond the perception of isolated minds? There is beauty in this terror, a poetic inevitability that stretches across the infinite. The multiverse, in its silent, ceaseless expansion, holds a mirror to our own fragility, our fleeting consciousness, our yearning to understand what it means to be real. And so the question lingers, suspended like a star on the edge of a collapsing horizon. If the multiverse were to fold upon itself, what becomes of reality itself? Long before the language of modern science emerged, humanity gazed at the sky and wondered if our reality was but one thread woven into a vast, unseen tapestry. The atomists of ancient Greece imagined worlds beyond perception, spheres of matter, spinning in an infinite void, each with its own destinies. Across the continents, Hindu cosmology spoke of innumerable realms, eternally cycling through creation and dissolution, hints of multiplicity embedded in the rhythm of time itself. These were not equations, nor observations, but the first tremors of a question that would haunt the human imagination for millennia. Could reality itself be plural? In the mid-20th century, the question moved from philosophy into the strange, counterintuitive world of quantum mechanics. Hugh Everett, in 1957, proposed a daring interpretation that every quantum choice, the flicker of an electron, the decay of a nucleus, branches reality into multiple, coexisting outcomes. In his many worlds interpretation, the universe was no longer a single unfolding narrative, but a forest of possibilities, each as real and vivid as the one we inhabit. Initially, his ideas were met with skepticism, dismissed as metaphysical fancy. Yet quietly, they seeded a radical shift in understanding, hinting that the cosmos might be far more expansive than any telescope could reveal. At the same time, cosmologists, exploring the aftermath of the Big Bang, began to uncover hints that our universe was not alone. The theory of inflation, refined over decades, suggested a violent, exponential growth in the earliest moments of existence. In some regions, inflation never ceased, giving birth to pockets of space-time bubbles of reality, each evolving independently, a cosmic landscape of universes beyond counting. Observations of the cosmic microwave background, the afterglow of creation itself, offered subtle anomalies, cold spots, and asymmetries that defied simple explanation. Whispering of regions beyond our horizon, perhaps the footprints of other worlds, debates raged quietly in physics corridors. For years, the multiverse was considered speculation, a poetic diversion from empirical science. Yet slowly, it was reconsidered, recognized not as fantasy but as a consequence of the mathematics and the observations themselves. It became clear that the multiverse is less a discovery than a mirror, a reflection of humanity's longing to grasp infinity, to see the vastness of existence mirrored in our own small awareness, and to confront the silent question that lingers. Beyond every theory, how vast is the cosmos, and how fragile is the story we call reality? As the 20th century progressed, the multiverse shifted from speculation toward a framework in which our own universe became a single example in a vast ensemble. The quantum mechanical roots of the idea were subtle but profound. In Everett's many worlds interpretation, reality splits at every quantum event, so that every potential outcome of every decision, no matter how small, exists in a parallel trajectory. It is a vision both exhilarating and unnerving. In some distant branch, there may be a universe where our civilization never arose, or where entire histories unfolded differently. These branches, though imperceptible to us, are mathematically consistent, arising inevitably from the same equations that govern our reality. Eternal inflation added another layer of awe and unease. Unlike the finite expansion imagined in early Big Bang models, inflation suggested that space could grow without bound, spawning pockets where the laws of physics themselves could vary. Each bubble, each nascent universe, carries its own constants, its own cosmic history, creating a panorama in which our reality is only one among countless possibilities. In some corners of this cosmic expanse, gravity might behave differently, chemistry might yield strange atomic structures, and life as we understand it might never emerge. And yet, within this staggering diversity, our universe exists, precarious, familiar, and remarkably fine-tuned, a quiet island of order amid an ocean of infinite potential. Observational hints, though subtle, have tantalized scientists with the possibility that we might one day glimpse these other realms. Anomalies in the cosmic microwave background, the faint relic radiation from the Big Bang, suggests that the universe may bear scars from interactions with regions beyond our own. Cold spots, regions of slightly lower temperature than expected, challenge our understanding of cosmic uniformity. Some researchers speculate that these could be the fingerprints of neighboring universes, faint echoes of collisions in the primordial landscape of space-time, though no definitive evidence yet exists. The very suggestion stretches the imagination, confronting us with the possibility that the cosmos is more interconnected than stranger than our senses allow us to perceive. The multiverse was and remains a battleground of ideas. When the concept first emerged, it was largely dismissed as metaphysical, a philosophical indulgence with no place in rigorous physics. Many feared that entertaining the multiverse risked undermining the empirical foundations of science, and yet, as the mathematics of quantum mechanics and cosmology matured, the notion could no longer be ignored. It revealed itself not as a whimsical hypothesis, but as a consequence of the very frameworks we use to describe reality. Physics, in this sense, became an invitation to confront infinity, forcing humanity to wrestle with questions both terrifying and sublime. Throughout this unfolding journey, there is a poetic symmetry to the multiverse's emergence. Ancient thinkers sought to understand the cosmos through myth, philosophy, and abstraction, imagining worlds beyond the visible. Modern science, in its pursuit of precise equations and observations, arrives at a vision uncannily similar: countless universes, branching, expanding, colliding, existing beyond the horizon of perception. It is a testament to the human mind's persistent curiosity, a recognition that our longing to comprehend infinity is as enduring as the stars themselves. Yet, the multiverse is not merely a distant abstraction. It forces reflection on our place within reality. If every possibility unfolds somewhere, then the events of our lives, triumphs, failures, choices are mirrored endlessly across branches we may never touch. There is both liberation and vertigo. In this realization, our actions are simultaneously inconsequential and infinitely significant. In contemplating the multiverse, we confront the delicate balance of determinism and randomness, order and chaos, existence and non-existence. The philosophical weight deepens when considering the implications of multiple universes coexisting. Some cosmologists have speculated that interactions between these universes could leave detectable traces, that reality itself may be malleable at scales far beyond our current understanding. Such interactions are hypothetical, yet they remind us that the cosmos is not static, but a living, evolving phenomenon, full of mysteries that transcend human perception. Even the notion of causality, the simple idea that one event follows another, becomes fluid in a multiverse context. What seems inevitable within one branch may be but one of countless possibilities when viewed across the totality of all realities. There is also a mirror here, a reflection of humanity's enduring existential longing. The multiverse offers a framework in which every dream, every fear, every version of the self exists somewhere. It is a humbling reminder that the universe is vast beyond comprehension, and yet intimately connected to the observer who seeks to understand it. In this sense, the multiverse is less a discovery of external worlds and more a revelation of the internal landscape of human imagination. Every theory, every equation, is a dialogue with infinity, an attempt to map a cosmos that may ultimately resist full understanding. As contemporary physics has progressed, the multiverse has moved from the realm of abstract theory towards serious scientific discourse. Researchers in string theory, quantum gravity, and cosmology explore the mathematical necessity of multiple universes. Eternal inflation remains a central pillar, supported by high-precision measurements of cosmic expansion and the subtle structure of the cosmic microwave background. The debates continue. Some view the multiverse as an elegant solution to fine-tuning problems, while others question whether its hypotheses are truly testable. Regardless of consensus, the multiverse compels us to expand our philosophical and scientific imagination, challenging the boundaries of what is knowable. The multiverse also reframes fundamental questions about origin and destiny. If our universe is but one of countless realms, what does it mean to begin or end? The Big Bang, long considered a singular event, may be one bubble in a ceaseless cosmic ocean, each universe born, evolving, and fading in rhythms far beyond human perception. In this light, existence is no longer a linear narrative, but a vast, multi-dimensional symphony composed of infinite harmonics, each vibrating with the potential for life, for consciousness, for observation itself. Ultimately, the story of the multiverse is a reflection of human yearning. It is a story of minds reaching beyond the visible, of equations seeking patterns in chaos, of poets and physicists alike grappling with the profound question of infinity. From ancient atomists to modern cosmologists, from the whispered speculation of philosophers to the rigor of quantum mechanics and inflationary theory, the multiverse embodies a bridge between the known and the unknowable. It challenges perception, stretches imagination, and invites a humble acknowledgement that our reality, wondrous and intricate as it is, may be one of an uncountable multitude, each universe a mirror, each existence a fleeting illumination against the dark, eternal ocean of possibility. In the end, the multiverse is not a discovery in the conventional sense. It is less an empirical finding than a testament to humanity's unending quest to understand the cosmos. It is an acknowledgement of the infinite complexity of reality and our desire to situate ourselves within it. Every anomaly, every speculative theory, every mathematical derivation is a whisper across the eons, a reminder that the universe, or rather the multiverse, is as much a reflection of human consciousness as it is an external reality. And in contemplating it, we confront the quiet, persistent mystery at the heart of existence itself, the boundless, shimmering, and unfathomable infinity in which our story, and all stories, unfold. When Hugh Everett first unveiled his many interpretation in 1957, it landed like a quiet tremor in the foundations of physics, a subtle disturbance that would ripple for decades. At its core, the idea was simple. Every quantum choice, every flicker of chance, does not resolve into a singular outcome. Instead, it branches, creating parallel realities where each possibility unfolds. Yet simplicity in mathematics belied the radical nature of the claim. The universe, Everett suggested, was not a single story with a clear narrative arc, but a forest of coexisting realities, each as real and vivid as the one we inhabit. Four physicists, steeped in the Copenhagen interpretation, championed by Niels Bohr and his followers, Everett's vision was more than counterintuitive, was heretical. Copenhagen had long dominated quantum thought, asserting that measurement collapses uncertainty into a single reality. Probability was confined, observation decisive. To suggest that every possible outcome occurs somewhere, simultaneously, was a challenge to the very logic that had guided the field for decades. Everett's theory was dismissed by many as metaphysical indulgence, a mathematical curiosity with no bearing on real physics. Colleagues offered polite skepticism, some open disdain, and Everett retreated from the limelight, leaving his ideas to simmer quietly on the edges of academic discourse. Yet the ripples persisted among the younger physicists and those willing to interrogate the assumptions of quantum orthodoxy. Everett's vision sparked fascination. The idea that reality might split endlessly, producing a branching tree of existence, was simultaneously beautiful and unsettling. It suggested that every choice, every accident, every flicker of chance was recorded somewhere in the cosmos, a permanent echo across the architecture of reality. Slowly, quietly, what had been dismissed as folly began to take on a serious tone. An inevitable consequence of the mathematics underpinning quantum theory. The irony of the story is unmistakable. Everett, initially isolated, became a figure of posthumous recognition. Many worlds, once ridiculed, would eventually be cited in seminal papers, debated in conferences, and referenced in studies of quantum computation and decoherence. Yet the road to recognition was not only scientific, but deeply philosophical. The idea unsettled fundamental notions of identity, causality, and reality itself. If every choice produces a new branch of existence, what is real? What anchors experience in a world where countless alternate versions of ourselves may exist, each pursuing different destinies, each unaware of the others. Public fascination mirrored and amplified this tension. Popular science outlets embraced Everett's ideas with enthusiasm, portraying parallel worlds as a playground for imagination, speculation, and narrative. Media fascination transformed what was once a technical footnote into a cultural phenomenon. Readers were drawn to visions of alternate selves, of histories that might have unfolded differently, of infinite possibilities shimmering just beyond perception. Yet this fascination contrasted sharply with academic caution. While the public marveled at infinite branching, physicists remained rigorous, emphasizing that speculative interpretation cannot replace empirical verification. Many worlds, as alluring as it was conceptually, remained difficult to test directly, leaving a tension between the rigor of science and the narrative appeal of imagination. Within physics, the theory inspired intense reflection on the foundations of quantum mechanics. The measurement problem, the question of why observations yield definite outcomes, remained unresolved. Everett's framework offered one answer: the universe never collapses into one outcome. All outcomes exist, just in different branches. Subsequent research into quantum decoherence provided indirect support, showing that interference between branches becomes negligible in macroscopic systems, effectively isolating realities from one another. In this light, many worlds evolved, from a speculative musing into a credible interpretive tool, capable of explaining phenomena that Copenhagen struggled to reconcile. The philosophical anxieties, however, lingered. If reality splits endlessly, then notions of identity, causality, and morality take on new dimensions. Every decision, every act of creation, destruction, kindness, or violence is mirrored across countless universes. Our lives, intimate and consequential in one thread, are repeated, altered, and transformed in others. There is both liberation and vertigo in this vision, freedom from determinism, yet a haunting sense of cosmic indifference. The singularity of existence, once comforting, dissolves into a tapestry of infinite possibility. The universe is no longer a stage for a single story, but a vast theatre of branching narratives, each as significant and as ephemeral as the next. Everett's idea also exposed the human longing for certainty. Science thrives on predictability, on frameworks that allow calculation and understanding. Many worlds confronts us with the impossibility of total comprehension, a reminder that the cosmos may resist singular narratives. Yet this disturbance, far from undermining physics, invigorates it. It forces deeper inquiry into the mathematics of quantum theory, into the nature of information, and into the boundaries of what can be observed. It challenges assumptions, provokes debate, and stimulates new experiments. In this sense, Everett's contribution is emblematic of scientific progress itself, disruptive, unsettling, and ultimately illuminating. The narrative of initial rejection and later recognition carries a broader lesson. Every revolutionary idea, whether in physics, mathematics, or philosophy, begins as a disturbance in certainty. Copernicus, Galileo, Einstein, and Everett each faced skepticism, ridicule, or incomprehension. Yet the persistence of ideas, their capacity to illuminate unseen patterns, gradually reshapes understanding. Everett's many worlds interpretation is a testament to this trajectory, a reminder that what is dismissed today may, with reflection and evidence, become foundational. Tomorrow, moreover, the story of many worlds speaks to the human desire to explore infinity. The theory resonates not only because it solves equations or resolves paradoxes, but because it mirrors our existential curiosity. It is a lens through which to examine the fragility of identity, the nature of choice, and the breadth of reality itself. It invites reflection on the role of consciousness in a universe that may be far more intricate than the singular narrative we inhabit. In confronting the multiverse, humanity confronts itself, recognizing that understanding the cosmos is inseparable from understanding the mind that perceives it. As scientific tools and computational models grow more sophisticated, the many-world interpretation continues to inspire both theoretical exploration and philosophical reflection. Experiments in quantum entanglement, information theory, and cosmology probe the subtle structures that might, indirectly, confirm the branching nature of reality. Each measurement, each data point, becomes a whisper of the underlying complexity, a hint that Everett's vision may not be mere speculation, but an unavoidable consequence of the universe's mathematical fabric. Ultimately, the first reactions to Everett's theory reveal the interplay between bold ideas and cautious scrutiny, between imagination and empirical rigor. They show how science, in its most profound moments, requires both courage and patience, embracing concepts that disturb the comfortable certainties of established thought. And they remind us, with quiet insistence, that the cosmos is rarely what it seems. What begins as radical, as heretical, may in time redefine our understanding of reality, challenging us to reconsider the very nature of existence, choice, and consciousness. Everett's many worlds interpretation, once marginalized, now stands as a testament to the transformative power of ideas. It embodies the tension between certainty and wonder, between observation and speculation, and between the finite perspective of human consciousness and the infinite expanse of possibility. In contemplating the multiverse, physicists and philosophers alike are forced to confront profound questions. What does it mean to be real, to act, to decide, to exist? And in the quiet space between uncertainty and insight, the echoes of Everett's vision continue to resonate. A reminder that the greatest discoveries often arrive as disturbances, subtle, persistent, and ultimately reshaping our understanding of reality itself. In the quiet aftermath of Everett's revelation, the multiverse ceased to be merely a speculative footnote and began to take shape as a structured, almost tangible framework. The human mind, ever restless, sought to categorize the infinite, to render the incomprehensible into conceptual architecture. Max Tegmark, standing at the frontier of theoretical cosmology, offered a hierarchy of multiverses, a ladder ascending from the familiar to the unimaginable. Level I, the simplest, extended the observable universe, envisioning distant regions so far that light has yet to reach them, yet governed by the same physical laws. Level II introduced universes arising from eternal inflation, where the very constants of nature might differ, producing realms that are familiar yet subtly alien. Level 3 embraced Everett's many worlds branching, where every quantum event splits reality into countless paths. Level 4, the most abstract, proposed the existence of universes governed by entirely different mathematics, structures as alien as a language we cannot hear and a geometry we cannot imagine. Each level is a reflection, a facet of possibility, and together they form a tapestry of potentialities that stretches beyond comprehension. A cosmic horizon without end. Physicists sought to tether these conceptual towers to the scaffolding of known science, String theory, with its vast landscape of possible vacua, provided fertile ground. In this framework, the fundamental building blocks of reality strings and brains could configure themselves in near-infinite ways, each arrangement producing a universe with its own laws, its own particles, its own history. The landscape is not an abstract metaphor but a mathematical inevitability, suggesting that our universe may simply be one among countless realizations of the underlying cosmic code. Yet this richness introduces a paradox. If infinite possibilities exist, how can any single universe be distinguished? How can scientific inquiry, grounded in observation, hope to touch a reality that may forever lie beyond empirical reach? In response, theorists turned to the power of computation. Early simulations of cosmic inflation attempted to model the emergence and branching of universes, the stochastic proliferation of space-time bubbles, and the statistical distribution of their properties. These simulations revealed landscapes of staggering complexity, fields of energy that rippled, bubbled, and collided, producing nascent universes whose laws varied subtly or profoundly. The patterns that emerged were at once illuminating and humbling. The branching of reality, the birth of cosmic domains, the unfolding of independent histories all became objects of calculation. Yet their scale defied full human comprehension. The simulations suggested that the multiverse is not merely an idea but a domain whose vastness mirrors the limits of perception itself. A structure so intricate that no finite mind could fully grasp it. Thought experiments flourished alongside computation. Schrödinger's cat, once a parable of quantum uncertainty, became a gateway into branching realities. In one universe, the cat lives. In another, it dies. Observation itself became a bridge between worlds, an act that entwines consciousness with the cosmic flow. Physicists and philosophers explored infinite quantum branches, probability trees, and hypothetical bubble collisions, constructing mental laboratories where the imagination could roam freely. Each scenario was an experiment in reasoning, a reflection on the delicate balance between determinism and possibility, between choice and inevitability. In these thought experiments, the universe becomes both a playground and a mirror. It reveals not only the contours of reality, but also the contours of the human mind, its curiosity, its fear, and its relentless drive to explore the unfathomable. Yet even in the midst of mathematical elegance and computational exploration, a profound tension remained. The multiverse is, by its nature, largely unobservable. If other universes exist beyond our cosmic horizon or within inaccessible quantum branches, can they ever be known? The question of testability looms like a shadow over theoretical speculation. Some critics argue that the multiverse may lie forever outside the purview of empirical science, a tantalizing abstraction, a mathematical inevitability that cannot be confirmed. Others contend that indirect evidence patterns in the cosmic microwave background, statistical anomalies, or the fine-tuning of physical constants might one day offer glimpses into the wider ensemble of realities. In this tension, the multiverse becomes both a scientific frontier and a philosophical provocation, confronting the limits of knowledge while inviting audacious imagination. The early investigations revealed another, more subtle truth. The pursuit of the multiverse illuminates less about the universe than about the human mind. In modeling infinite possibilities, in imagining alternate histories and quantum branches, humanity confronts its refusal to accept limits. The simulations, the equations, the thought experiments are acts of defiance, attempts to map the immeasurable, to name the unknowable, to touch infinity with finite tools. They reflect a persistent desire not only to understand the cosmos, but to situate ourselves within it, to assert agency in a universe that may be far larger and more indifferent than we can perceive. Even the language used to describe these early investigations carries a poetic resonance. Cosmologists speak of landscapes, bubbles, branching trees, and vast oceans of possibility. These metaphors are not mere ornamentation. They are the only tools adequate to evoke the scale and richness of the multiverse. Words become instruments of imagination, allowing minds tethered to finite experience to glimpse the infinitude that stretches beyond the observable. In these descriptions, the line between science and philosophy blurs, and the act of scientific investigation becomes inseparable from reflection on existence itself. Throughout these explorations, certain recurring patterns emerge. The branching of universes mirrors the branching of thought. The proliferation of possibilities reflects both quantum dynamics and human curiosity. Each simulation, each theoretical model, each thought experiment is both a probe into reality and a mirror of consciousness, revealing how deeply entwined the observer is with the observed. The early work on multiverse categories, string landscapes, and computational models does not merely chart unknown worlds. It charts the boundaries of imagination, showing how far reasoning and curiosity can extend when confronted with the infinite. There is also a quiet philosophical elegance to this period of early investigation. While the multiverse challenges conventional notions of reality, it does so with mathematical rigor, suggesting that even the most fantastical possibilities are bound by consistent principles. Infinity, here, is not chaos but structure, vast, intricate, and unfathomable, yet coherent. The human mind, in attempting to map this structure, discovers both its limits and its capacities, recognizing that understanding is not simply the accumulation of facts, but the expansion of perspective. In probing the multiverse, humanity confronts not only the cosmos, but its own cognitive horizon. The threshold where certainty gives way to wonder. By the close of these early investigations, a subtle truth becomes apparent. The multiverse, for all its mathematical and theoretical complexity, is also a mirror of human longing. The drive to categorize, simulate, and imagine reflects a refusal to accept the boundaries of perception. Each simulation, each level of Tegmark's hierarchy, each bubble in a cosmic landscape embodies a desire to transcend limitation, to glimpse the infinite, and to wrestle meaning from the boundless. In this, early investigations illuminate as much about the observer as the observed, revealing that the pursuit of knowledge is inseparable from the pursuit of understanding one's place in a cosmos that may be far larger, stranger, and more intricate than previously imagined. In the end, the first explorations of the multiverse serve as both map and mirror. They chart potentialities beyond reach, while reflecting the inexhaustible curiosity that drives human thought. The simulations and theoretical models are not merely tools for describing the universe. They are instruments for expanding the mind, for confronting infinity, for asserting agency in a reality that resists total comprehension. In probing the infinite, humanity discovers the contours of its own imagination, the unyielding desire to know, and the persistent refusal to accept limits even in the face of the unknowable. The cosmos has always spoken in whispers, but in the last decades, those whispers have grown louder, resonating across the instruments and observatories that hum quietly on Earth and in orbit. the Planck satellite, mapping the cosmic microwave background with unparalleled precision, revealed patterns that defied expectation. Amid the gentle afterglow of the Big Bang, cold spots appeared regions cooler than the surrounding universe, anomalies subtle yet unmistakable. For some, these were statistical fluctuations, mere artifacts in the grand map of the cosmos. For others, they hinted at something more profound, the faint, frozen footprints of another universe, brushing against our own, leaving a spectral trace in the sea of radiation. The idea is almost unbearable in its elegance and implication. Our universe, so vast and seemingly self-contained, may bear scars from encounters beyond the observable horizon, echoes of realities we can only imagine. Gravitational wave detections added a new layer to this fragile architecture of possibility. As LIGO and Virgo measured the ripples in space-time from colliding black holes and neutron stars, theorists began to speculate. Could some of these signals carry signatures not of our universe alone, but of interactions with others? Collisions between universes, poetic and terrifying possibility, might imprint subtle distortions. Waves that propagate through the fabric of space-time, whispers of other cosmic domains bleeding into our own. Though currently speculative, the notion reshapes the boundary between observation and imagination, suggesting that the universe may not be an isolated arena but a stage on which multiple realities occasionally touch, intertwine, and perhaps leave traces behind simultaneously. The enigmatic fine-tuning of the universe continued to haunt physicists and philosophers alike. Constants of nature, the strength of gravity, the charge of the electron. The cosmological constant are exquisitely calibrated to allow stars to burn, planets to form, and life to emerge. Any slight deviation would render the universe sterile, lifeless, incomprehensible. String theory, with its vast landscape of possible vacua, provides a context for this apparent precision. Each universe in the multiverse carries different parameters, but only those where conditions permit observers to exist are experienced. In this framework, our existence is neither guaranteed nor inevitable, but contingent, a delicate resonance in an infinite ensemble of possibilities. The unsettling consequence is anthropic reasoning, the notion that the universe appears finely tuned because we are here to perceive it, a reflection of both cosmic contingency and the fragile specificity of life. Observers began to ask whether the universe might carry more tangible traces of its siblings. Collisions with other bubble universes in the inflationary multiverse could leave faint scars. Concentric rings or anomalies in the microwave background, subtle asymmetries hinting at cosmic contact. The search became a meticulous exercise in statistical precision and interpretive humility. Each anomaly is debated, measured, remeasured, its significance weighed against the backdrop of noise and chance. Even in failure, these investigations are profound. They stretch the imagination of science, insisting that observation is never merely passive, but an invitation to wonder. The philosophical weight of these possibilities is immense. If our universe bears fingerprints of others, the boundaries of reality dissolve. Existence is no longer singular, but interwoven with the infinite. Human consciousness, observing, measuring, and theorizing, becomes both participant and witness in a larger cosmic dialogue. Our instruments may detect only faint traces, our understanding only shadows, yet each data point whispers of the deeper architecture of existence, of realms unseen and events unfelt, of universes whose tangential presence shapes our own in ways we are only beginning to comprehend. Yet for all these tantalizing hints, certainty remains elusive. The multiverse does not yield its secrets easily. It offers suggestion, probability, and speculation. Cold spots, gravitational waves, fine-tuned constancy are fragments, fleeting glimpses into a tapestry far larger than the observable. They invite interpretation but deny conclusion, calling on scientists and philosophers alike to dwell in the tension between knowledge and wonder. Each observation deepens the mystery, echoing the quiet, persistent refrain that the cosmos is far stranger and more intricate than any singular model can encompass. In the Planck maps, in the hum of gravitational wave detectors, in the precise values of fundamental constants, the universe speaks not in answers but in hints, in quiet anomalies that tease and beckon. These signals suggest a reality layered, infinite, and intertwined, a reality where our universe is but one of countless threads in a vast, unending weave. Each measurement, each anomaly, each carefully scrutinized data point is a reminder that science is an act of both courage and humility, a confrontation with the limits of perception and the enormity of possibility. Humanity, standing at the threshold of understanding, must reconcile awe with rigor. The evidence for other universes, however indirect or subtle, challenges assumptions of isolation and singularity. The very act of searching, the patient observation, the statistical modeling, the delicate calibration of instruments becomes a meditation on existence itself. Science, in these moments, transcends calculation. It becomes philosophy, an inquiry into the nature of reality and our place within it. Ultimately, these breakthrough observations do not deliver certainties but questions. They invite reflection on the scale and subtlety of the cosmos, on the fragile specificity of life, and on the possibility that we are participants in an ensemble far greater than our perceptions allow. Cold spots in the microwave background, whispers of gravitational waves, the uncanny precision of physical constancy hint at an underlying structure that is simultaneously mathematical, physical, and profoundly mysterious. They suggest that reality is not singular but multi-layered, that our universe may bear the faint, ghostly imprints of its companions, and that existence itself is a dialogue between the observable and the unseen. In the end, each observation whispers not certainty but mystery. The multiverse, once a speculative abstraction, begins to leave its fingerprints on the cosmos, subtle, elusive, and beautiful. And in that silence, in the delicate tremor of data that hints at worlds beyond our own, humanity encounters the sublime, a vast, intricate, and unfathomable reality, where each measurement is both an answer and a question, where the universe, in all its silent grandeur, continues to challenge, inspire, and enthral. As the evidence and theory of the multiverse expanded, so too did the shadows that lurked at its edges. With every model and every observation, a paradox emerged. Probability itself became uncertain. In an infinite ensemble of universes, how can one assign meaning to likelihood, to chance, to expectation? The measure problem in cosmology reveals this tension. In an unbounded multiverse, any event that can occur will occur infinitely many times. Yet the relative frequency, the concept of probability, loses its familiar grounding. Every possible history unfolds somewhere, yet distinguishing one from another becomes an exercise in abstraction, a confrontation with the limits of calculation. The cosmos, it seemed, was willing to obey its own mathematics while defying human intuition, offering a landscape of infinite possibility that our tools of logic can scarcely grasp. Quantum mechanics, once confined to the microscopic, offers its own illumination and its own haunting. Decoherence, the process by which quantum superpositions become effectively classical through interaction with the environment, lends credence to the realness of branching worlds. A particle is no longer merely probable. Each potential outcome exists in parallel, insulated by decoherence into distinct threads of reality. Schrödinger's cat is not merely a thought experiment. It is a template for existence itself, a hint that the branching of worlds is not metaphor but a physical, measurable process, even if direct observation remains impossible. Yet the deeper we look, the more unsettling the picture becomes. If branching occurs at every quantum event, then the universe is not a single narrative, but an endlessly proliferating library of realities, each as vivid, as consequential, as real as the one we inhabit. The question grows: is the multiverse physics or philosophy? Does it belong in the laboratory, where empirical evidence must govern interpretation, or in the mind, where abstraction and speculation can roam freely? The giants of modern science grappled with this tension. Stephen Hawking, with his mastery of black holes and cosmology, weighed the possibilities of inflationary bubbles and the limits of observation. Leonard Susskind argued for the string landscape, embracing the vast multiplicity of vacuum states and the anthropic reasoning they entail. Max Tegmark classified multiverses with elegant hierarchy, translating abstraction into categories that could guide inquiry. Roger Penrose, ever skeptical, reminded the community of the necessity for physical grounding, questioning whether mathematical elegance is sufficient to establish reality. Across decades, their debates oscillated between exhilaration and unease, each insight revealing new complexity, each challenge exposing gaps in understanding. As the dialogue unfolded, a subtle shift began to take shape. The multiverse, once imagined as a collection of isolated bubbles, began to reveal an underlying entanglement. Quantum theory suggests that nothing is entirely separate, that even distant branches may retain correlations, hidden connections woven into the fabric of reality. Universes may not merely exist side by side. They may influence one another subtly, their fates intertwined through principles that are only now beginning to be explored. In this entangled vision, reality is less a mosaic of independent tiles and more a dynamic, interdependent web, where events reverberate across realms, where the act of observation in one branch may have echoes elsewhere. Yet the entanglement introduces further philosophical and scientific tension. How can one interpret correlations that are beyond direct observation? How does one ascribe meaning to phenomena that exist outside the causal horizon? The boundary between physics and philosophy blurs, and the pursuit of knowledge becomes inseparable. From the act of reflection, to explore the multiverse is to confront the limitations of certainty, to grapple with questions that may have no final answers. Measurement, probability, causality, identity all are challenged by the suggestion that existence is simultaneously singular and manifold, that every choice and every event resonates in a cascade of parallel realities. The tension manifests not only in theory but in methodology. Cosmologists attempt to define measures, to assign probabilities to infinite sets, yet every choice of measure brings new ambiguities. In trying to quantify the likelihood of events across infinite domains, one is confronted with paradoxes, infinite repetition, indeterminate ratios, the seeming collapse of conventional logic, and yet this challenge is also profound inspiration. It forces a re-evaluation of what it means to know the universe, reminding us that even mathematics, the most exact of tools, is a lens filtered through human perspective, limited by the finitude of comprehension. Quantum decoherence continues to illuminate and confound. Experiments reveal interference patterns fading in complex systems, effectively isolating quantum branches into distinct realities. Each branch, though inaccessible to direct observation, is nonetheless implied by the mathematics. The universe, it seems, is inherently redundant yet exquisitely precise. The proliferation of possibilities does not devolve into chaos, but organizes itself through decoherence, forming the scaffolding of parallel existence. In these insights, science and philosophy converge. The multiverse is simultaneously tangible and elusive, observable only indirectly, inferred through patterns and principles rather than through immediate perception. The reflection deepens when one considers human existence within this framework. Our lives, choices, and experiences become threads woven into an intricate cosmic tapestry, infinitely replicated and varied. Each decision branches into myriad outcomes, each life a prism splitting into countless reflections. Consciousness, observation, and identity are cast in a new light, not as singular experiences, but as part of an expansive, interconnected web. In contemplating the multiverse, humanity confronts a mirror. The structure of reality reflects the structure of thought, and vice versa. The cosmos and consciousness are entwined, each illuminating the other in a dialogue that is at once empirical, philosophical, and profoundly human. The debate among the giants, the entanglement of universes, the paradoxes of probability, converge into a single, haunting realization. The multiverse is not simply an answer to scientific questions. It is a lens through which to examine the limitations of understanding itself. Reality, once thought definable and singular, becomes a dynamic interplay of mathematics, physics, and consciousness, a domain where certainty is provisional and observation is partial. In seeking to grasp the multiverse, humanity discovers the boundaries of perception, the subtle interplay of structure and uncertainty, and the profound humility required to engage with the infinite dot. By the close of this inquiry, the multiverse has transformed. It is no longer merely a scientific model or speculative framework. It has become a mirror reflecting our inability to define reality with certainty. Probability, branching, entanglement, and observation converge into a portrait of existence that is at once beautiful, unsettling, and inexhaustible. Each insight deepens the mystery, revealing that understanding is not a matter of accumulation, but of perspective, of recognizing that the universe and perhaps all universes resists confinement within the bounds of human comprehension. In the end, the multiverse does not yield definitive answers. It whispers, it hints, it unfolds in patterns that tease and inspire. Through decoherence, entanglement, and the paradoxes of probability, it forces reflection on identity, causality, and the scope of knowledge itself. Reality, in this vision, is not singular, measurable, or absolute. It is layered, branching, and entangled, a cosmos of infinite reflections that challenges the human mind to perceive without closure, to wonder without finality, and to contemplate the vast, mysterious, and sublime nature of existence itself, at the extreme edge of scientific thought. Where mathematics and imagination converge, the multiverse assumes forms that defy ordinary intuition. The notion of universe collisions emerges from the intricate geometry of brane cosmology, where our familiar three-dimensional space is but a membrana, brane floating within a higher dimensional expanse. Other branes, parallel yet imperceptible, may drift, oscillate, and occasionally collide. Such a collision would not merely shake the local cosmos. It would ripple through dimensions, birthing phenomena both sublime and catastrophic, imprinting traces on the fabric of reality itself. The universe, in this vision, is not isolated but intimate with an ensemble of other worlds, interacting across unseen dimensions, whispering to one another in the subtle language of gravity and energy. Theoretical physicists push these ideas to the edge of what can be conceived. Simulation hypotheses propose that even our universe might be a computational artifact, a sophisticated projection running on a substrate beyond comprehension. In these models, the cosmos itself becomes a data structure, branching and evolving, according to rules embedded in an underlying system. While initially speculative, such frameworks offer a conceptual bridge between physics, information theory, and metaphysics, hinting that the very nature of reality may be relational, constructed, and algorithmic, rather than fixed and absolute. Here, at the boundary of theory, science and philosophy entwine, and the act of conjecture becomes an experiment in imagination. Cyclical cosmologies add another layer to this vision. Across deep time, universes may be born from the deaths of predecessors, emerging from collapses and expansions in an endless chain of creation. Big bangs may be preceded by other bangs. Universes may recycle, mutate, and evolve, producing structures and laws that shift subtly across iterations. Time itself, in this picture, is not linear but serpentine, looping back upon itself in a cosmic dance. The consequences are profound. Our universe, exquisite in its apparent singularity, may be merely one verse in an eternal poem of creation. Each cosmos a stanza echoing from the last, resonating across scales of space and time that transcend comprehension, even mathematics, the most precise instrument of human thought, encounters the ineffable here. Set theory and paradoxes of infinity loom over cosmological speculation. Consider Hilbert's Hotel, a structure of infinite rooms, always capable of accommodating more, yet trapped in an unending logic of paradox. The multiverse mirrors this abstraction, suggesting realms so vast that counting, probability, and even measure lose conventional meaning. Infinity is no longer a symbol but a property of reality itself, a landscape where the finite human mind attempts to navigate without compass. These analogies illuminate not only the cosmos but the limits of cognition, showing that the act of theorizing is inseparable from confronting the ungraspable. Yet these extreme ideas encounter the ultimate boundary, experimental falsification. The multiverse, by its very definition, stretches beyond the reach of observation. Universes beyond our horizon, dimensions beyond perception, branches beyond interaction, these are inaccessible to direct measurement. Theoretical constructs, however elegant or compelling, reside on the threshold where physics meets speculation. Yet this is not a failure, but a revelation. In confronting the unfalsifiable, scientists explore not just reality, but the limits of what it means to know, to measure, and to interpret. In these shadows, the multiverse becomes both a scientific challenge and a philosophical meditation, a mirror of the unknown, a space where courage and imagination become instruments of inquiry. The edge of science is a strange and haunting place. concepts once relegated to fiction, the collision of universes, the computational architecture of reality, the endless cycle of creation, the paradoxes of infinity become formalized into equations, simulations, and theoretical landscapes. Here, mathematics and physics serve as both lantern and ladder, illuminating vistas that are otherwise inaccessible, allowing the human mind to ascend toward heights where observation is impossible. Yet comprehension is attempted. Every model, every calculation, every conceptual experiment stretches understanding into realms that cannot be touched, demanding both rigor and surrender, clarity and humility. Brain collisions, computational universes, and cyclical cosmologies converge into a vision that is simultaneously exhilarating and terrifying. The universe may be a node in an intricate web, a thread in a tapestry woven across dimensions, iterations, and probabilities. Existence itself may be relational, contingent, and interconnected in ways we are only beginning to perceive. Observation and measurement become acts of interpretation, constrained not only by instruments but by the very structure of reality. Science, at this frontier, is less about discovery and more about engagement, an acknowledgement that the cosmos may resist final comprehension, yet yields glimpses of profound elegance and order in contemplating infinity. The human mind encounters both its limits and its aspirations. Hilbert's Hotel, with its infinite rooms, illustrates the strange malleability of the unbounded. No matter how many guests arrive, space remains accommodating yet incomprehensible. Similarly, the multiverse, in its vastness and subtlety, accommodates every possibility without exhaustion, yet eludes the completeness of understanding. Each theoretical framework, brain cosmology, simulation hypotheses, cyclical models serves as a lens to apprehend this vastness, not to contain it, but to engage with it, to measure the immeasurable, to map a reality that is at once ordered and infinite. In this extreme landscape, the human imagination becomes a critical instrument. Calculations and equations provide structure, but intuition and contemplation guide the exploration of what lies beyond reach. The multiverse becomes a space where thought itself extends, where philosophy and physics converge, and where the observer must reckon with the sublime, the tension between knowledge and the unknown, between possibility and proof, between the finite mind and the infinite cosmos. Experimental boundaries remain stark, while indirect hints cosmic microwave anomalies, gravitational waves, fine-tuning of constant suggest broader realities. Direct falsification remains impossible. The multiverse exists, in many ways, as a horizon rather than a measurable entity, a conceptual territory that challenges assumptions about causality, observation, and proof. Yet it is precisely at these boundaries that the human mind encounters wonder. To confront the unobservable is to engage with the sublime, to recognize that reality may be far more layered, interconnected, and exotic than any single model can capture. Ultimately, at the extreme edge of science, the multiverse is both a dream and a haunting shadow. It embodies the aspiration to transcend limits, the yearning to comprehend infinity, and the courage to explore what may never be fully grasped. Each collision, each theoretical simulation, each infinite sequence of universes invites reflection on the fragile specificity of our existence and the vastness that surrounds it. The multiverse, in this light, is not merely a hypothesis, but a meditation, a mirror reflecting the extraordinary scope of possibility and the humility required to confront the unbounded. In these realms, physics becomes poetry, and mathematics becomes meditation. The multiverse challenges perception, defies closure, and inspires awe. It reminds humanity that even at the apex of knowledge, the cosmos may extend beyond understanding, that the edge of science is at once luminous and shadowed, and that the pursuit of truth is inseparable from the acceptance of mystery. Each equation, each model, each speculative leap is a step along a precipice, a journey to the limit of comprehension, where reality is at once known and unknowable, where the universe stretches outward, infinite and silent, waiting for thought to reach toward it. And so, at the extreme edge, the multiverse stands as both a promise and a shadow, a dream constructed from the language of physics, mathematics, and imagination, and a haunting reminder that the cosmos may always extend beyond what can be measured, calculated, or fully comprehended. To explore it is to confront infinity itself, and to dwell within that confrontation is to experience the profound exhilaration and sublime mystery of existence. The cosmos, when seen through the lens of contemporary physics, reveals a reality far more expansive and intricate than intuition allows. Among the prevailing frameworks, eternal inflation offers a vision both mesmerizing and disquieting. In this model, the universe is not a singular explosion into void, but a continuous, self-reproducing process. Quantum fluctuations in the inflaton field drive pockets of space to expand faster than light, creating bubble universes in an endless froth of creation. Each bubble, isolated yet governed by the same fundamental laws of physics, may evolve. Differently, one may form galaxies and stars, another remain a barren, lifeless expanse. The boundaries between bubbles are subtle, rarely interacting, yet their existence is implied by the mathematics of inflation itself, a silent testimony to the fecundity of the cosmos. Our universe, luminous and structured, is but one bubble, adrift in a sea of infinite possibility, a single verse in an eternal, unending hymn of creation. Parallel to this, quantum mechanics whispers a startling idea. Every possibility is realized. Hugh Everett's many worlds interpretation, once dismissed as speculative, proposes that the universe branches continuously at each quantum event. A particle exists not in a single state, but in all possible states simultaneously, each realized in a distinct branch of reality. Every flicker of choice, every uncertainty, gives rise to a new world. Schrödinger's cat, alive and dead, is not a paradox, but a window into the branching tapestry of existence. The universe becomes a vast, ever-dividing tree, with each branch equally real, yet inaccessible to its siblings. Human decisions, cosmic events, even the formation of galaxies, are woven into this infinite proliferation of realities. In this framework, existence is not linear, but labyrinthine, each path realized, each possibility a thread in an intricate, inexhaustible fabric. String theory offers its own vision of multiplicity. Within its complex landscape, the mathematics allows for an estimated y distinct vacuum states, each corresponding to a potential universe with unique physical constants and laws. The equations do not dictate a single outcome, but a vast array of possibilities, each as valid as the next. The apparent fine-tuning of our universe gravity, the cosmological constant, the strengths of fundamental forces is, thus, less a miraculous coincidence than a statistical inevitability within a multiverse of unimaginable breadth. Somewhere in this cosmic ensemble, conditions are precisely suited for stars, planets, and life to emerge, and here we find ourselves, in the rare and delicate pocket of possibility that permits observation. The anthropic principle, once a philosophical curiosity, becomes a survival lens. Our existence is not inexplicable but contingent, a consequence of being in a universe capable of sustaining observers. Observational science, though constrained by the limits of measurement, reaches tentatively into these vast realms. Cosmic microwave background, anomalies, cold spots, unusual alignments, subtle asymmetries may hint at the influence of neighboring bubbles. Gravitational waves, rippling through space-time from violent cosmic events, invite speculation. Could some echoes originate from interactions beyond our universe? Each observation is delicate, ambiguous, yet suggestive, forming a lattice of indirect evidence that both tantalizes and frustrates. Scientists navigate between mathematics and measurement, using the cosmos itself as a laboratory for ideas that stretch the limits of perception. The mainstream multiverse is no longer a whimsical conjecture. It arises naturally from the best-tested theories of physics, inflationary cosmology, quantum mechanics, and string theory. Yet its existence is simultaneously elusive and inevitable, a reluctant child of science that refuses to conform to the constraints of observation. It challenges the very notion of what a universe is, suggesting that our reality is one node in an infinite network of possibilities, where chance, law, and structure intertwine. It is a cosmos, both rigorous and mysterious, governed by equations, yet permeated with wonder and eternal inflation. The sea of bubble universes stretches beyond comprehension, each bubble an isolated cosmos, yet part of a continuum of creation. Quantum branching ensures that every uncertainty is realized, forming an infinite lattice of realities. String theory's landscape frames these possibilities within a mathematical order of staggering complexity. Each vacuum a universe, each constant a potential variation. Observation, though indirect, lends the faintest support, suggesting that anomalies in the cosmic microwave background or subtle gravitational echoes may be the first faint imprints of this vast multiplicity. At the intersection of theory and observation, the multiverse becomes simultaneously scientific and philosophical. It is a framework that preserves empirical rigor while acknowledging the limits of detection. It is a universe of infinite repetition, infinite divergence, and infinite possibility. The human mind, confronted with such enormity, finds both solace and disquiet. Solace in the mathematical consistency and philosophical beauty, disquiet in the impossibility of complete verification. The mainstream multiverse embodies a tension inherent in the scientific endeavor, the pursuit of truth balanced against the recognition that some truths may remain forever out of reach. This vision reframes existence, life, consciousness, and the cosmos itself are cast as contingent outcomes in an endless ensemble. Every choice, every fluctuation, every formation of matter participates in a process that is at once deterministic and endlessly varied. Human understanding becomes a lens focused on a single node in a vast network, capable of grasping patterns but never the entirety. The multiverse challenges perception, demanding a reckoning with scale, probability, and the very nature of reality. In this framework, observation and theory are inseparable. Anomalies in the cosmic microwave background, the structure of space-time, the fine-tuning of constants all converge to suggest a cosmos that is both vast and structured, indifferent yet intelligible. The mainstream multiverse is grounded in physics, yet it evokes wonder and philosophical reflection. It is a reality that resists singular definition, revealing that science, in its most ambitious form, is not merely a catalogue of facts, but a method of engaging with infinity itself. Ultimately, the mainstream multiverse is a reluctant offspring of science. It emerges from equations, experiments, and observation, yet transcends their confines. Eternal inflation, quantum branching, string landscapes, and anthropic reasoning form a cohesive narrative of multiplicity, each element reinforcing the others, yet all converging toward a horizon of mystery. It is a vision that is rigorous and speculative, measurable and unreachable, elegant and humbling. This multiverse is a mirror, reflecting both the cosmos and the human endeavor to comprehend it. It is a framework that accommodates every possibility, that explains the improbable, fine-tuning of existence, and that situates life and observation within a grander structure of infinite breadth. The universe, in this context, is no longer an isolated stage, but part of an unending, interconnected ensemble, where laws, constants, and probabilities weave an intricate, inexhaustible tapestry. Science has given rise to the mainstream multiverse, not as a story of fiction, but as a consequence of its most profound theories. It is rigorous in its derivation, tentative in its verification, and staggering in its implication. It stretches imagination to the limits of reason and perception, inviting reflection on existence, contingency, and the ultimate nature of reality. In the quiet hum of laboratories, in the meticulous mapping of cosmic radiation, in the subtle ripples of gravitational waves, the multiverse whispers its presence. It is at once a scientific hypothesis and a philosophical meditation, a framework that challenges the human mind to consider the infinite while standing firmly in the finite. In the end, the mainstream multiverse is neither fully tangible nor entirely abstract. It is a domain where physics confronts philosophy, where mathematics hints at infinity, and where the faintest observational clues illuminate a reality far broader than immediate perception. It is science's reluctant child, born of the pursuit of understanding, nurtured by theory, and ever hovering at the edge of certainty. To engage with it is to confront the immensity of possibility, the delicate specificity of existence, and the enduring mystery that lies at the heart of the cosmos, at the outermost periphery of cosmological thought, where imagination and mathematics entwine. The multiverse assumes forms so radical that they border on the sublime. Among these speculative landscapes, the idea of universes merging captivates with its audacity. What if, instead of drifting in isolation, bubble universes or branching worlds could collapse into a singular cosmic structure? In this vision, the manifold of realities, each with its own laws and constants, coalesces, not violently, but gradually, like tributaries converging into a single river. The immense diversity of existence folds upon itself, histories intertwining, possibilities overlapping, creating a universal, perhaps a meta-universal, intricate that every prior distinction is subsumed into a new, overwhelming totality. The mathematics suggest a mechanism rooted in higher dimensional interactions, overlapping branes, entangled quantum fields, and gravitational interconnections capable of guiding these convergences. Yet the phenomenon, if it occurs, remains beyond the reach of direct observation, a cosmic choreography inferred only through patterns subtle enough to evade detection, yet persistent enough to intrigue theorists. Quantum entanglement offers a tantalizing complement to this vision. Across conventional distances, particles can exhibit correlations that defy classical explanation, suggesting a fundamental interconnectedness woven into the fabric of reality. Fringe cosmologists propose that such entanglement could extend across entire universes, providing a channel through which reality convergence becomes possible. Two or more universes might, in principle, share information or influence, their quantum states subtly nudging each other into coherence. Such a mechanism transforms existence from isolated epochs into a vast, interactive network where causality is not strictly local and the boundaries between realities become porous. Observation, measurement, and even the act of consciousness may propagate influence across universes, creating ripples that are imperceptible yet theoretically consequential. Time, in these speculative frameworks, assumes a new and extraordinary role. Not merely a sequential ordering of events, but a unifying field across which parallel timelines may fold and intersect. The familiar linearity of cause and effect dissolves, replaced by a dynamic manifold where moments recur, converge, and blend. Past, present, and future lose the rigidity imposed by perception, becoming pliable and relational, each timeline a strand in an intricate temporal tapestry. Universes may fold into one another, each branch folding inward until distinctions vanish, leaving a singular, multi-layered reality that contains echoes of all possibilities. The idea is extreme, yet it follows logically from the mathematics of higher dimensional space-time and certain interpretations of quantum cosmology, where the geometry of time is as flexible as the geometry of space. The mathematical multiverse pushes abstraction further still. Here, every conceivable structure exists equally and unconditionally, not merely physical universes or quantum branches, but all logically possible realities, spaces with laws utterly alien, dimensions where geometry itself behaves unconventionally, patterns of matter and energy that defy any familiar classification. In this vision, the cosmos becomes an arena of pure potential, an infinite ensemble of existence where every coherent configuration is realized. Mathematical existence, in this sense, is sufficient for ontological reality. Logic itself becomes generative, and the multiverse is a landscape of all patterns, where reality and possibility are indistinguishable, and where human perception is but a narrow window into an unbounded plenitude. Perhaps the most provocative and unsettling of these fringe theories is the notion of consciousness-driven universes. Quantum mechanics teaches that the act of observation collapses probability into actuality. Extend this principle across worlds, and consciousness itself becomes a cosmic architect. Observers, by perceiving, might not merely record reality but participate in its formation, selecting among potential universes, biasing outcomes across branching multiverses, or even synchronizing probabilities across distant realms. Life, thought, and awareness are no longer epiphenomena, but active participants in the orchestration of existence. The universe becomes inseparable from those who inhabit it, a vast feedback loop in which observation and structure coexist, each influencing the other in subtle and profound ways. Each of these ideas is speculative, yet their exploration reveals something essential about the human mind and the scientific impulse. Where measurement falters, imagination persists. Where falsification fails, reason and mathematics extend the reach of understanding. The fringe of cosmology is not mere fantasy, is the territory where intuition, logic, and theory converge, where the boundaries of comprehension are tested, and where the conceptual frameworks of science are stretched toward their most audacious limits. Even if some proposals prove untenable, their existence inspires new approaches, new mathematics, and new thought experiments. They are laboratories of the mind, arenas where curiosity meets infinity, Observational hints, though sparse, continue to inspire reflection. Cosmic microwave background irregularities, unexplained cold spots, subtle anomalies in gravitational wave detections. Anomaly fuels speculation about convergence, entanglement, or consciousness-mediated phenomena. These are not confirmations, yet they provide texture to the theory, glimpses of possibilities that challenge the strictures of classical physics. They remind us that even at the edge of knowledge, the universe retains its capacity to surprise. In these speculative frameworks, the very nature of existence is called into question. Is reality singular or plural? Is time linear or malleable? Do observers shape the cosmos or merely witness it? Each theory, from merging universes to consciousness-driven outcomes, confronts these questions in ways that expand the horizon of understanding while emphasizing the limits of certainty. Science here is inseparable from wonder. The multiverse is no longer a distant abstraction, but a mirror reflecting both the vastness of possibility and the fragility of perception. Fringe theories remind us that speculation is the fire that fuels discovery. They allow physicists, mathematicians, and philosophers to explore not only what exists, but what might exist, to navigate realms where intuition falters and imagination leads. At the extreme edges of cosmology, the cosmos is a canvas for thought itself, and each hypothesis, no matter how radical, serves to illuminate the boundaries of knowledge, the structure of reality, and the profound mysteries that remain just beyond perception. These speculative visions share a common thread. The universe, or multiverse, is not fixed or singular. It is dynamic, interconnected, and, in some models, participatory. Universes may merge, timelines may fold, mathematical structures may exist independently, and consciousness may echo across reality itself. Each scenario, grounded in reason and mathematics, yet extending beyond direct verification, challenges conventional notions of space, time, causality, and identity. They form a gallery of possibilities, a meditation on what it means to exist, to observe, and to imagine at the edge of physics and philosophy. These radical ideas evoke awe as much as they provoke doubt. To contemplate universes converging, timelines folding, and consciousness shaping reality is to confront both the grandeur and the fragility of existence. The multiverse, in this vision, is a space of infinite creativity, an arena in which every conceivable law, every possible configuration, every potential observer is realized in some manner. The cosmos becomes simultaneously structured and wild, knowable and inscrutable, offering both patterns and profound uncertainty. Through these lenses, the speculative multiverse reveals a deeper truth, that human inquiry, even when pushed to extremes, is defined not merely by evidence, but by the courage to imagine beyond what is observed. These theories, no matter how tentative, extend the frontier of thought. They challenge assumptions, inspire new mathematics, and provoke reflection on the very meaning of existence. At the furthest reaches of theory, science becomes both discovery and meditation, a dialogue between certainty and possibility. In the final reflection, the fringe multiverse is neither proven nor entirely testable, yet it is indispensable. It embodies the willingness to ask the unanswerable, to imagine beyond constraints, and to explore the profound consequences of possibility itself. Each radical hypothesis, universes merging, quantum convergence, temporal folding, mathematical reality, consciousness-driven branching is a lens through which to examine existence, a thought experiment of cosmic proportions, and a mirror reflecting the human drive to understand infinity. At the outer edge of knowledge, the multiverse is both a dream and a shadow. It embodies the tension between speculation and evidence, imagination and measurement, philosophy and physics. Here, at the frontier, curiosity becomes the guiding principle, and the act of questioning becomes an exploration as profound as any experiment. The multiverse, in its most speculative form, challenges not only what we know, but how we know it, revealing the infinite possibilities that lie beyond observation, and the enduring mystery that defines the cosmos. And so, in contemplating the speculative multiverse, one is drawn into a space where science, philosophy, and imagination converge. It is a realm of radical possibility, a testament to the audacity of thought, and a reminder that the fire of speculation illuminates the path to discovery. At the edges of understanding, the universe and the multiverse beckons, vast, enigmatic, and inexhaustible in the quiet corridors of modern astrophysics. The cosmos speaks in faint murmurs. Among the instruments of observation, the Planck satellite and its successors map the cosmic microwave background with exquisite precision, seeking the faintest imprints of realities beyond our own. These minute fluctuations, cold spots and subtle anomalies, are scrutinized for patterns that might hint at neighboring universes. The data is immense, the noise overwhelming, yet within this celestial static, researchers search for signatures that could reveal the hidden architecture of the multiverse. Each deviation, each irregularity, is a potential window or ripple in the infinite pond of existence. A whisper of worlds beyond sight, quantum computing offers another portal into these profound questions. Experiments in superposition and entanglement, once confined to microscopic systems, now scale toward macroscopic regimes, probing the interface between probability and reality. Quantum computers, manipulating states that exist in simultaneous multiplicity, become more than tools, they are laboratories for the imagination, allowing researchers to explore the mathematical landscapes of many worlds' interpretations. Each qubit represents a branching path, a microcosm of potential universes realized in parallel computation. In this synthetic multiverse, the abstract becomes tangible, and theoretical speculation gains a form of experimental traction, however provisional, gravitational. Wave astronomy has opened a new sensory organ for the cosmos. LIGO, Virgo, and future observatories listen to the ripples of spacetime itself, detecting collisions of black holes and neutron stars with breathtaking clarity. Some theorists suggest that these waves might occasionally carry high echoes, disturbances originating not from our universe, but from adjacent ones, intersecting or brushing against the fabric of our own. The interpretation is subtle, fraught with ambiguity, yet the potential is tantalizing, a direct, albeit rare, sign that our universe is but one layer in a more complex manifold. These faint echoes, buried in noise, could be the first tangible evidence of a reality that extends beyond empirical immediacy. A bridge between observation and speculation. AI-driven cosmological simulations push the frontier further still. Algorithms now explore vast probability landscapes, modeling countless configurations of physical constants, energy distributions, and inflationary pathways. These virtual universes, while not real in the ontological sense, provide a laboratory of possibility, revealing which structures are probable, which are rare, and which may permit the emergence of complexity and life. Patterns emerge in silico that suggest connections between fine-tuning, vacuum stability, and multiverse scenarios. Researchers use these simulations to illuminate questions that experiments cannot yet answer, allowing theory to navigate landscapes too vast for human computation alone. Interdisciplinary approaches are increasingly vital. Physicists collaborate with mathematicians, philosophers, and computer scientists to frame the multiverse, not merely as a scientific model, but as a conceptual lens through which to explore reality. Questions of measure, probability, and definition, once dismissed as metaphysical, become central to interpretation. What does it mean to exist in a probabilistic ensemble? How can observation, consciousness, and information be reconciled with a universe that is inherently branching and infinite? These questions lie at the intersection of empirical science and philosophical reflection, a space where thought experiments are as crucial as laboratory measurements. The search for the multiverse, in its current phase, is both meticulous and tentative. It is a pursuit defined not solely by the desire for confirmation, but by the recognition that existence itself may be more layered and intricate than direct observation allows. Data from cosmic microwave background studies, gravitational wave detection, quantum experimentation, and computational modeling are assembled into a mosaic, each piece partial, each hint suggestive rather than conclusive. Within this endeavor, researchers confront the limits of knowledge while expanding the boundaries of understanding, probing not only the cosmos, but the nature of inquiry itself. Every experiment, every simulation, every anomaly observed in the heavens becomes part of a larger narrative, the human attempt to situate consciousness, life, and physical law within a structure that may be infinite, multidimensional, and interconnected in ways barely conceivable. Multiverse research is a meditation on scale and contingency, a recognition that our universe may be an infinitesimal yet significant expression of a far broader ensemble. It is the pursuit of comprehension in the face of infinity, an exploration where certainty is rare, yet insight emerges from the layering of subtle patterns and statistical inference. Even the act of questioning is itself revelatory. By seeking multiverse signatures, scientists illuminate the implicit assumptions underlying cosmology, testing the robustness of inflationary models, the constancy of fundamental laws, and the nature of initial conditions. The endeavor forces a reckoning with probability, how to define measures across infinite ensembles, how to distinguish meaningful anomalies from statistical noise, how to interpret subtle correlations in data that span billions of years and unimaginable scales. These challenges are not merely technical, they touch the philosophical core of what it means to study reality in laboratories and observatories. Across continents and disciplines, the search for the multiverse proceeds with patience and rigor. Every gravitational wave event, every qubit manipulated in superposition, every anomaly in the cosmic background radiation is meticulously catalogued, modeled, and interpreted. The work is incremental, often frustratingly inconclusive. Yet cumulatively, it builds a map of possibility, a framework for understanding existence that extends beyond the confines of our singular universe. The journey also reflects the human dimension of science, curiosity, perseverance, and a willingness to engage with questions that may never yield final answers. To explore the multiverse is to confront the limits of perception, the finitude of observation, and the vastness of theoretical imagination. It is to navigate a landscape where evidence is partial, where certainty is provisional, and where the act of inquiry itself becomes as important as any potential conclusion. Ultimately, the search for the multiverse is less about proof than about perspective. It is an endeavor that situates humanity within a cosmos of staggering complexity, highlighting both the contingency and the coherence of existence. It invites reflection on the delicate balance of laws and constants that permit observation, life, and understanding, and it fosters humility in the face of scales that exceed human intuition. Scientific efforts, from data mining to quantum experimentation to AI-driven simulation, form a chorus of inquiry, each voice adding nuance and depth to the emerging narrative of a universe that may be but one among countless others. These contemporary efforts also illuminate the symbiotic relationship between theory and experiment. Observations guide speculation, simulations test mathematical models, and philosophical reasoning shapes interpretation. In this way, the multiverse becomes both a scientific hypothesis and a conceptual mirror, reflecting the profound interplay between knowledge, imagination, and existence. It is a pursuit that embodies the tension between the measurable and the speculative, between certainty and wonder, and between the finite mind and the infinite cosmos. As research advances, even null results are informative. The absence of detectable multiverse signatures constrains models, informs inflationary parameters, and sharpens the definitions of probability across potential universes. Each limitation is a guidepost, directing inquiry along viable paths, while reminding us of the subtlety and intricacy of nature's design. Science, in this context, becomes an exploration of possibility as much as an accumulation of facts. A dialogue with the cosmos conducted at the edges of perception, in the convergence of physics, computation, and philosophy. The multiverse emerges as both a hypothesis and a meditation. It challenges the boundaries of observation, yet it is grounded in the most rigorous theoretical frameworks. It reminds us that existence may be far vaster, more varied, and more interconnected than the visible universe alone would suggest, and it compels reflection on the human place within this broader ensemble, a recognition that observation, inquiry, and consciousness are themselves threads woven into the fabric of a cosmos, whose full tapestry may forever elude complete apprehension. Ultimately, the current scientific efforts to probe the multiverse are a testament to human curiosity and intellectual courage. They illustrate that the pursuit of understanding does not always yield immediate answers, but each step, each measurement, each simulation, each theoretical refinement brings us closer to glimpsing the vast, intricate, and profoundly mysterious architecture of reality itself. It is a search defined not by closure, but by the deepening of perspective. A meditation on existence conducted at the frontiers of knowledge, and a reminder that the universe, in its grandeur, is always more than it first appears. Here, at the edge of empirical inquiry, science meets philosophy, mathematics meets imagination, and the act of exploration becomes a reflection on the infinite. The search for the multiverse is not a quest for proof alone, it is a profound engagement with the nature of existence, the subtle interplay of laws and probabilities, and the enduring human desire to understand not just the universe we inhabit, but the full expanse of possibility itself. In this endeavor, every signal, every simulation, every calculation contributes to a larger story, a story of curiosity, rigor, and wonder, stretching across the cosmos and into the very heart of being, at the edge of cosmological thought, where physics flirts with philosophy. The multiverse becomes not only a structure of matter and energy, but a mirror for human contemplation. Infinite versions of ourselves may drift across countless realities, each a variation on choices, circumstances, and chance. Yet, in imagining a collapse of the multiverse, a convergence of all possibilities into a singular thread, a profound question emerges. What becomes of identity when the many fold into one? The familiar markers of self-memory, experience, perception might not merely be altered. They may be dissolved, reframed, or revealed to have always been fragments of a larger, unified whole. Individuality, once a fortress of certainty, could yield to an overwhelming interconnectedness, a recognition that each I was never isolated, but a reflection of all potential selves. This philosophical tension reverberates through the concept of free will. If every possible choice exists somewhere in the branching labyrinth of universes, does agency retain its significance? In one branch, a decision is decisive. In another, its opposite occurs. Across the infinite expanse, every path is traveled, every possibility realized. Yet the collapse suggests a new frame. Perhaps choice is meaningful not in isolation, but in its convergence. The multitude of paths, once independent, merge, and the significance of action is transformed, not erased. The collapse does not annihilate possibility. It reframes it, revealing patterns that were invisible amid the chaos of branching. Free will becomes a reflection of coherence emerging from multiplicity, an echo of the human yearning to make sense. Of complexity, within this cosmic meditation, lies the fragility of identity. If the multiverse converges, the I experienced in any one universe may not endure in its familiar form. Memories, perceptions, and histories might intertwine with those of other selves, creating an existence that is simultaneously personal and collective. The individual may dissolve into a composite, yet in that dissolution, something profound is revealed. The boundaries that define identity are less rigid than imagined. Humanity's insistence on separateness, the sense of self as isolated, may be a temporary lens, a perceptual necessity rather than an absolute truth. The collapse forces a reckoning with this fragility, inviting a contemplative awe rather than despair. Human meaning itself is entwined with the narrative of convergence. Across civilizations, philosophy, art, and science have sought unity in diversity, threads connecting disparate experiences into a coherent tapestry. The multiverse, in its infinite expanse, mirrors this human aspiration. Its potential collapse can be interpreted not as loss, but as revelation, a cosmic reflection of the desire to reconcile multiplicity with singularity, chaos with order, potential with actuality. The convergence of universes embodies the symbolic pursuit of unity that humanity has long sought in moral systems, aesthetic ideals, and philosophical inquiry. Yet, within the enormity of such an event lies a quiet tension. The collapse is not merely abstract, it confronts the emotional imagination. The disappearance of alternate selves is both tragic and consoling. Tragic because each branching existence, each version of love, failure, and triumph ceases to exist independently. Consoling because the convergence may reveal that these infinite narratives were never isolated but threads contributing to a single, coherent story. In this sense, the multiverse becomes a metaphor for consciousness itself, a multitude of experiences and possibilities coalescing into the perception of a singular, meaningful reality. Time and causality, too, assume a reflective hue in this contemplation. Where branching worlds once diverged endlessly, the collapse suggests a temporal reconciliation. Events that seemed disparate may align into a continuum, a cosmic narrative whose shape is discernible only through the lens of convergence. The past, present, and future are not lost. They are woven together, forming patterns that illuminate the nature of existence itself. The sensation of linear progression may dissolve, revealing a timeless coherence in which all outcomes, all experiences, and all selves contribute to the emergent story of reality. The human psyche, confronted with such speculation, oscillates between awe and vertigo. Infinity collapses, not as a distant abstraction, but as an intimate reflection of self. Each person is both an actor and observer within an infinite ensemble. And yet the collapse suggests that individuality and universality are not opposed. They are intertwined. Consciousness, memory, and identity are reframed as expressions of the same underlying fabric that connects every universe, every possibility. Every choice in this reframing human existence is neither diminished nor trivialized. It is elevated, becoming simultaneously finite in perception and infinite in participation. Ethics and responsibility, long grounded in singular narratives of cause and effect, also encounter profound questions. If infinite versions of every action exist, what weight does moral choice carry? The collapse intimates a subtle answer. The significance of choice is not in isolation, but in contribution to coherence. Each action, each decision, each observation is part of a larger pattern that binds multiplicity into unity. Morality and meaning emerge not from absolute uniqueness, but from the relationships between possibilities, from the way each eye resonates with the collective chorus of selves. Human significance is transformed into participation in the unfolding structure of reality itself. This reflection extends beyond the individual to society, culture, and knowledge. Human understanding, which builds cumulatively across generations, mirrors the cosmic narrative. Just as branching universes eventually converge, so do thoughts, discoveries, and experiences contribute to an emergent coherence in the collective consciousness. The pursuit of science, art, and philosophy is a miniature echo of the multiverse itself. Disparate efforts contributing to patterns larger than any single perspective, weaving threads of understanding into a tapestry that encompasses the many. And the one dot in this light, collapse, is not annihilation but revelation. It reframes the infinite not as a threat to meaning but as a canvas for reflection. Every life, every choice, every branching path is recognized as part of a grander coherence. A single story told in countless variations. The seeming loss of diversity is balanced by the emergence of unity. A pattern in which multiplicity finds resolution without erasing significance. Consciousness, identity, and existence are preserved, transformed into a broader harmony that is simultaneously intimate and universal. Human longing, reflected in this contemplation, is mirrored in the cosmos. The drive to understand, to reconcile the many with the one, to find patterns amid chaos, is echoed in the very structure of reality. The multiverse, whether collapsing or branching endlessly, serves as a cosmic metaphor for the search for meaning. Its study invites humility, wonder, and reflection, revealing that the boundaries between science, philosophy, and human introspection are porous and interdependent. In this sense, the collapse of the multiverse is both literal and symbolic, a phenomenon that reframes reality while reflecting the deepest human questions. Ultimately, if the multiverse were to collapse, it may not signal an ending, but a revelation. That reality was always one story, told in infinite ways. Each branching universe, each version of self, each possibility contributes to a coherence that transcends observation. Identity, choice, and existence are both preserved and reimagined in the convergence. The infinite, paradoxically, illuminates the singular, and the singular reflects the infinite. Human consciousness, poised at the edge of comprehension, finds, in this reflection, a quiet awe, a meditation on unity, and a profound recognition of being within the cosmos. Through this philosophical lens, the multiverse becomes more than a physical hypothesis. It is a narrative framework, a poetic mirror in which the human mind can explore its own relationship to existence. Collapse is not merely the erasure of multiplicity, is the revelation that multiplicity and unity have always been intertwined. The infinite variations of life, choice, and reality converge to illuminate a fundamental truth that what we perceive as distinct, separate, and fleeting is, at its core, part of a singular, eternal story. In contemplating the fate of infinite selves, the fragility of identity, and the emergence of unity from convergence, humanity is invited to reflect on its own place within the cosmos. To consider the multiverse is to confront both the grandeur of possibility and the intimacy of being. It is a meditation on how multiplicity and coherence, chaos and order, choice and inevitability coexist, revealing a cosmos in which the search for understanding is inseparable from the search for meaning. And so, in the quiet meditation on a collapsing multiverse, the human mind encounters its most profound reflection, that existence, in all its apparent divergence, may ultimately be a single, coherent narrative. Infinite selves, infinite choices, infinite worlds all converge to tell one story. And in that convergence, there is not only revelation, but a profound, philosophical serenity. It is here, at this intersection of science and reflection, that the multiverse becomes a mirror of the human quest to understand, to integrate, and to perceive that even amid infinity, reality is ultimately one.